Hi everyone, let's do a quick intro on carbocation structure. Carbocations are carbons bearing a positive formal charge. Carbocations are incomplete octet species, okay, and the carbon possesses an empty p orbital, so it's really important. Carbocations are incomplete octet, and they possess an empty p orbital. If you look at this here on the right, we have a carbocation. Notice how here it's making 3 bonds, okay, just 3 bonds, this carbon of positive charge. And there's this empty p orbital. This is specifically an example of an sp2 carbocation, and the vast majority of carbocations that you'll look at are sp2 hybridized. An example of a carbocation that is not sp2 but rather sp hybridized is a vinyl carbocation, or we could say there's this positive charge on a carbon that is already pi bonded. Okay, this carbon will be sp hybridized. Why? Well, it has one p orbital to engage in the pi bond with the adjacent carbon, and then it has an empty, we're going to say an empty p orbital by virtue of there being this positive formal charge on the carbon. So the vast majority are sp2, that's if there is no pi bond to the carbon, it's only making sigma bonds. And some select carbocations, which you will discuss, are sp hybridized, but those carbocations are also engaging in a pi bond, okay? So carbocations are highly reactive species. They are short-lived. And of course, there is a spectrum of stability when it comes to carbocations. And in the next couple of videos, we will be discussing the factors that stabilize carbocations. For right now, in this intro video, I want you to think carbocations are stabilized by both resonance, which is pi electron donation, and by hyperconjugation, which is also sigma donation. We have sigma electron density that can be donated to stabilize a carbocation, and we also have pi electron density that can be donated to stabilize a carbocation. But I really want to stress this. When you see a carbocation, I want you to think that carbon is only making 3 bonds, as opposed to neutral carbons, which engage in a total of 4 bonds. All right, that's really important so that you can remember if there should be a hydrogen there or not. For instance, you see this carbon is positively formal charged, you only see 2 bonds visually. The third bond that it would possess is to a hydrogen atom, okay? So carbocations make 3 bonds. The vast majority are sp2. When they're only otherwise sigma bonded, they are incomplete octet species. They have this empty p orbital, and they are stabilized by electron donation, and we can have both sigma and pi electron donation. Let's get into that. Hang tight.